So this is the next lesson in this unit. We're looking today at multiplying rational expressions. The nice thing about the way these next few lessons are going to progress is, for example, with today's lesson, you'll discover that really it's the same as what we did yesterday, last class. And for tomorrow's lesson, you'll discover that if for tomorrow's lesson we do one little thing, then it turns into stuff we know how to do today and last time. And the one after that, it's going to be the same. If you do something, it turns into the lesson from tomorrow. And if you do something to the question, then it turns into the stuff we know how to do today. And then other things happen. But for the next few days, it all devolves into factor and cancel, really, okay? So we're going to be finding non-permissible values for rational expressions that have multiple variables. We already did in the question that Zach asked about. There was an x minus y in the denominator. We're going to quickly go over that again. And then we're going to be multiplying rational expressions. To begin with, consider this rational expression. What expression represents the non-permissible values for x? Let's not worry about whether we can simplify this or not. If I said, what are the non-permissible values for x, you would say that 8x minus 6y can never be equal to 0. Right? Are you with me? Okay. Just checking. But that's true. That's a good non-permissible statement. Whatever x and y are, 8 times x minus 6 times y can never give you 0. But let's put it into something more understandable. Let's add 6y to both sides. I mean, this is maybe a little bit better. Whatever x and y are, you can use whatever numbers you want, but 8 times x better not be equal to 6 times y, because then the denominator is 0. Better yet, we can divide both sides by 8 and get x cannot be equal to 3/4 of y. So that's a non-permissible statement about what x is not allowed to be. Not that it really matters, but I'll just throw it out there. The statement at the bottom of the left tells us what x is not allowed to be in terms of y. The statement at the bottom on the right is telling us what y is not allowed to be in terms of x. They're the same statement. We usually write x is not equal to. All right, simplify the rational expression. So we factor. You cannot simplify, which means cancel, unless you factor. The numerator is a difference of squares. 16x squared is 4x quantity squared. 9y squared is 3y quantity squared. So the numerator factors as, I don't know that this has really been said to you, but a difference of squares factors into the conjugates. So 4x plus 3y, 4x minus 3y. Don't confuse this with what we were just talking about with the a minus 3 and 3 minus a. That's a different beast. And then we can take a 2 out of the denominator and end up with 4x minus 3y. How fortuitous, because we now have a factor of 4x minus 3y in the numerator and denominator, so we end up with 4x plus 3y over 2. Now, we did have non-permissible values, and you don't always need to do this, but it's better to do it than to not. And I'm going to try to explain why I think it's important to have it there. If that wasn't there, and all you were looking at, everybody, was that thing at the bottom of what I've written, it doesn't appear that there's any non-permissible values, does it? Because the factor that contained them is gone. But, and I can't remember in the video how much I stressed this, the non-permissible values are found by looking at stuff before you cancel. Just because you clear something away doesn't take away the fact that it was there to begin with and it's part of the expression. So you really ought to have that there. All right. Find the non-permissible value for y if x is 2.4. Well, we came to the conclusion that x cannot be equal to 3/4 of y. So what we can do is put 2.4 cannot be equal to 3/4 of y and solve that for y. Right? Multiply both sides by 4. And when I multiply both sides by 4, you better check out my arithmetic. I got a bit of a headache right now, and I might not be thinking clearly, but I think you get 9.6. Okay, and then you can divide both sides by 3 and get y is not allowed to be 3.2. Now, that's not a blanket statement about y. I'm not saying that y can never be 3.2. I'm just saying that when x is 2.4, y can't be 3.2. That's it. Are you with me on that? Determine if this is a pair of values that's allowed. So I guess there's a number of things you could do. Do you agree this is the statement, the non-permissible value statement? Okay, so let's see what x is not allowed to be when y is 2.8. Let's figure out what 3/4 of 2.8 is. And I want to say 2.1. So when y is 2.8, x is not allowed to be 2.1. So is this a pair of values for x and y that are allowed? Yes. Because when y is 2.8, x is not allowed to be 2.1, but x can be any other number you want. There's another way to look at this. Just help me out here. Was it 8x minus 6y? Yep. So 8x minus 6y is the denominator. It's not allowed to be 0. So you can go ahead and put in that x and that y and see what you get. You can go 8 times 1.5 minus 6 times 2.8. Negative 4.8. So negative 4.8. There's nothing in the realm of mathematics that says you can't divide by negative 4.8. Sure you can. So the denominator is going to be defined. Sorry, I shouldn't have said that. So the denominator will not be 0, which means the whole thing is defined, and that's allowed. So any questions with that first part of the lesson? Do you remember that it's easier to multiply and divide fractions than to add or subtract? The basic reason is that when you're adding or subtracting fractions, you need to convert everything to a common denominator. So normally addition and subtraction are things that in math you go, oh, that's easier than multiplying and dividing. Not with fractions. So that's why we're looking at multiplying and dividing fractions before we get to adding and subtracting. And all of the rules we learned for multiplying fractions can be applied to multiplying rational expressions. You'll notice that I was talking about multiplying and dividing, and now I'm focusing on multiplying. Dividing is tomorrow. Okay? Multiply the following fractions without using a calculator and express your answers in lowest terms. One of the things you learn, and the purpose here today is not for me to take you back and teach you the strategies you learned in junior high in terms of how you discovered them. Probably had something to do with algebra tiles, and I have no desire in the world to talk about algebra tiles. I think they're more confusing than anything else, but that's just me. One of the things you learned is that when you multiply fractions together, and I know I have an equals here, but don't go left to right. Don't go equals, equals, equals. You work down. One of the things you learn about multiplying fractions is you multiply the numerators together and you multiply the denominators together. And here's what I mean when I was talking about a few minutes ago, things turning into what we already know how to do. In that one stroke of the pen on the smartboard, I have changed this into a single rational expression. It's no longer two rational expressions, it's a single rational expression. It's a fractional expression, it's a numerical rational expression, if you want to call it something. But that means I can factor this completely. And again, I'm sure you remember, well, I don't know. I'm about to find out. What I'm about to write, please do not do, ever, that, you know, your teacher might go, oh, I can divide that by 3 and that by 3 and get 10 over 7, and I can write this as 7 over. Remember this mess? That's a nightmare to keep track of. If you think that's going to be helpful when we get to rational expressions, forget it, right? It's just not, it's going to be a disaster. So instead, and I've never really taught much junior high math, and maybe I'm thankful for that, but sometimes I think there might be better ways to teach junior high math to students. What you want to do is you want to write it this way and factor things. Now, I'm not saying you have to factor 30 down into 2 times 5 times. I'm not saying you have to do that, but what you can do is recognize that 30 is 6 times 5. We'll get to the 14, and I look on the bottom and I see a 12, and that's 6 times 2. So do you get my drift here that we're canceling factors? There's a factor in brackets of a 6 on the top, and there's 1 on the bottom. 21, I might as well factor that into 3 by 7. And 14 is 7 by 2. And we're not using a calculator. What we're using is a very low value times table. You know factors of 30, you know factors of 12. And then you say, I have a factor of 6 in the numerator and denominator, a factor of 7 in the numerator and denominator, a factor of 2 in the numerator and denominator. So what am I left with? 5 over 3. So this is equal to 5/3. So I guess what I'm doing here with these two numerical examples is I'm showing you how they're going to be the same as if they are rational expressions. Okay? So this becomes 4 multiplied by 9 on the top, and on the bottom 15 multiplied by 16. Now we don't have to factor everything completely. For example, I think you're perfectly aware that the 16 is a 4 times a 4. And all that's important there is I get a 4 on the bottom and a 4 on the top. Is there a common factor between 9 and 15? 3. So why don't I write the 9 as 3 times 3 and the 15 as 3 times 5? So the difference is this. When we get to the rational expressions in a minute, we want to factor everything completely, which means the 4 would be a 2 times a 2, but I don't think we need to with numbers. Cancel a 4 and a 4, a 3 and a 3. I have a 3 on the top, a 5 on the bottom, a 4 on the bottom. That's it. I'm left with 3 over 20. There is another difference too, in that you see how that 5 and the 4 got multiplied to give 20? When I do that with rational expressions, I would just probably leave it in factored form. There'd be nothing to be gained by multiplying it all out. All right. When you multiply any kind of fractions, you cancel a factor in any numerator with the same factor in any denominator. If you go back and look at this, do you see that this 4 came from the first fraction and this 4 came from the second fraction? Doesn't matter because we're multiplying, so ultimately it's one rational expression. I always dislike these questions. Because I'm telling you, you're supposed to factor first, right? I hope I can explain this right. I'm always leery about this. But there's nothing really to factor there, is there? It's a monomial. If I want to write it as 3 times 2 times 5 times x times y, I can. But I don't think you really need to. I'm just going to begin by writing this as 30 x squared y, 33 z cubed over 11 z squared 5x. I'm just packing them together. You multiply the numerators, you multiply the denominators.
Please contact the office, please. Mrs. Elder, please contact the office. Thank you.
Although what I'm about to show you is a nice little shortcut here, I don't want you taking it later. I don't want you taking it if it's algebraic instead of numerical. With the 30 on the top and the 5 on the bottom, I don't think anybody in the room needs to write 30 as 6 times 5. And then go, oh, there's a factor of 5, as if you're surprised. You know it's going to be leaving you with 6. Similarly, I think you know that 33 over 11 is going to give you 3 because 33 is 3 times 11. Now, with the rest of it, let's talk about the y's. Well, you only have y on the top. You don't have any factors of y on the bottom to cancel. Can somebody volunteer for me, please? The answer to this question. How many factors of x are on the top? 2, right? X squared means x times x. With monomials, we're not going to write x in brackets times x in brackets. We're going to say, we're basically using our exponent laws, x squared over x gives you an x. Z cubed over z squared gives you a z. If anything, you know these ones that are monomials, you're more likely, I think, to make a mistake with them because you got this, all this stuff going on in the background. But I'm getting 18 xyz. And x and z are not allowed to be 0. Why? Because x and z were both factors in the numerator or in the denominator of the original expression. Pretty good so far? Okay. So what should we do first? What should we do first? Factor. That's right, factor all the time. What do you do? Factor. What do you do? Factor. What do you do tomorrow? Factor. Factor, factor, factor. I hope you're okay with me just doing this and not putting multiplied in between them. I mean, I could just make it one big long fraction, but I'm going to leave it this way in preparation for something for tomorrow. The second rational expression, there's nothing to factor. The first rational expression has 2 trinomials that are quadratic, and they're of that basic quadratic form, where you're looking for numbers that multiply to give c and add to give the middle number, which is b. So for example, on the top, it's going to be x plus 2, x plus 5, because, and you'll notice that I just put that x plus 5 in brackets on the bottom all of a sudden, because 2 times 5 is 10 and 2 plus 5 is 7. And then this will be x plus 3, x minus 2. Whoops. So, do we have factors in the numerator and denominator that are identical? Yes. We can cancel this one with this one, and cancel the x plus 5 with the x plus 5, leaving us with x plus 2 over x minus 2. X is not allowed to be negative 3, positive 2, or negative 5. Because those 3 factors are in the denominator and they give us non-permissible values. I want to pause here for a second and explain what does this mean, because I think sometimes students in high school math just get so caught up in doing the math, they don't know why they're doing it. This is a simpler way to evaluate this top expression without doing all of the stuff in the top. So if I said, what do we get when we put 11 in for x up here? What do we get when we put x equals 11? Well, believe it or not, I think it's easier to come down to this point and then just figure out what this becomes when you put 11 in. I think if you put 11 every place there's an x at the top, you'll make more mistakes than if you just put it at the bottom. The answer is it's 13 over 9. All right, let's try another one. Well, this is what we were talking about with the question I think that Zach had asked about. That when you factor something like this top expression, just in your mind, blur out the y's. Pretend the y's aren't there. I mean, I will do it for you. I'll just white them out. And if I said to you, factor that, you'd just say, well, that's x plus 2, x plus 3. But that's not going to give us 6y squared for the last term. It will if it's 2y and 3y. And if you FOIL that out, you'll get the inner sum, the outer and inner sum added together of 5xy. So another way to kind of set this up is to say it's going to factor into this basic template, and you need numbers that multiply to give 10 and add to give 7. Well, that's 5 and 2. And then here, I guess it will be x plus y and x plus 5y, because 1 times 5 is 5 and 1 plus 5 is 6. I guess positive 3 and negative 1 would do it for the final piece. So can you do the math yourself? I know you're looking up here as you're working, but also think the math through yourself and make sure that you agree with me. I think we're okay. I want to just pause for one more thing. From now on, when we have expressions with multiple variables, I'm not going to worry about the non-permissible values in our daily work. Okay, we'll review it before the end of the unit, but for now it's just going to get in the way. So, well, it's a smorgasbord of cancellation, isn't it? When all the dust settles, we're left with x plus y on x minus y, or over x minus y. And there would be non-permissible values of x is not equal to y, x is not equal to a negative a half y, but I don't want to worry about that. We okay with that one? Eesh. So we want to factor everything completely. Don't be intimidated by this. This is your next one, right, D? Is it the final one? Okay. Don't be intimidated by this. Well, when we, in the unit called quadratic functions, we spent a lot of time just factoring. And it wasn't even about quadratic functions. It was just a review of factoring. And I said to you the same thing I would tell grade 10 students if I taught grade 10. You need to know how to factor. You can't look at this. Like if we go back to the previous unit in this course where we were doing some practicing of factoring, if it's going to take you 5 minutes to factor that, you're in trouble. Because we got 4 of those, well, 3, then something else. But let's just say it takes you even 3 minutes to factor those 4 things. That's 12 minutes. That's 12 minutes, and you haven't even gotten to the math 20, which is to cancel. So you need to be fairly proficient at this. You can't lag behind. But there are some tips and tricks I can provide to you. First of all, I would personally, well, won't do that. I would personally start with the 8r squared minus 50. And I would probably factor that on the side. I think that's one of the easiest parts of this to factor. And I'm doing it on the side because, let me put myself in your shoes. Let's say you go, I'm going to factor that first, and you take a 2 out, and you go 4r squared minus 25, and then you go, oh, that's a difference of squares. Do you want to rewrite the whole thing a second time just to do that difference of squares? Probably not. So maybe you want to do this in one shot. So when we take the 2 out of the 8r squared, we get 4r squared, and then minus 25. That's a difference of squares. 2r plus 5, 2r minus 5. And here's where the working smarter, not harder comes in. There are factors in the denominator that have 2r in them, which means if I go to, say, this one, I suspect it's going to be 2r and 3r. That's my suspicion. Why else would I give you something that's going to cancel if it doesn't cancel? And then I'm going to work smarter. I see that with the 2r's over here, there are 5's. So my suspicion for that green thing is this is a 5 and this is a 1. Now, it may not be, but it is. My inner product here is 15r. My outer is 2r. I need negative 13. So that means that this has to be a negative and this has to be a positive. You can't just go on your suspicions alone, but for example, when I look at the bottom of this, it's probably going to be 2r and 3r. And when I look at the top, there's a 1 with a 3r. Maybe, maybe not. Maybe something's going to happen elsewhere. But I might try this and then see if that works. And I'll leave that to you for a minute to see if what I've just written, here is factored correctly. I get 6r squared. I get negative 1. Do I, in fact, get negative r for the middle? Yes, I do. Well, what about the other piece? Well, again, I suspect it's going to be 3r and 2r. I'm going to ask, how many of you see that for that top piece that I haven't finished, it cannot be 2 and 2? Because if it's 2 and 2, you have made a fatal error because you've created a common factor of 2 that didn't exist in the original thing. Which means it can't be 2 and 2, it's got to be 4 and 1, and the 4 must go here and the 1 must go there. And I think that's factored correctly. Let's do our non-permissible values first. If I say, and you can decide whether you want to write this down or not, if it's written response, you should, but just in learning, you don't have to. If I say 2r minus 1 is not equal to 0 because that's a denominator, you should see why r cannot equal 1/2. If I say 3r plus 1 is not allowed to be 0, you should see why r is not equal to negative 3/2, negative 1/3. And you can continue with the other ones. So let's cancel. I have a 3r plus 1 is gone. I have a 2r minus 1. By the way, 2r minus 1, you might have guessed it was 1 and 4 based on the 2r minus 1 on the bottom. 2r minus 5. I think that's it. One of the, it's not tricky things, well, it's kind of, is after all of that, sometimes you miss pieces. You write down your answer and there's something you forgot to write. Like maybe you don't see that too. Anyway, what I'm getting is 3r plus 4 over 2 multiplied by 2r plus 5. Yep, that's it. So one of the nice things here from my standpoint is this is going to give you a workout with factoring. You know, number one, things are already factored for you. Then number two, you're going to have to factor things, and then things can get a little more complicated. If we have more than two rational expressions, it doesn't matter. You multiply across the top and across the bottom, so any factor on the top anywhere and any identical factor on the bottom anywhere, when you're multiplying, you can cancel. So that's it. A few questions to try for tomorrow. Tomorrow we will look at the exciting world of dividing rational expressions, which we turn into multiplying rational expressions with a twist, literally and figuratively.